Hey friends, it's Mrs. Walker. For our lesson today, we're going to talk about how we can use equal groups and repeated addition and use what we've already learned about that to talk about tape diagrams. So our learning goal for today says I can use tape diagrams to represent equal groups and relate the groups to repeated addition. So the materials that you'll need for this lesson are your dry erase board, about 20 counters. So make sure you grab those materials before you get started. All right, friends, so let's take a look at a word problem together. There are 20 apples in Jane's bag, 3 apples in Sam's bag, and 1 apple in Anne's bag. How many apples do the children have in all? So let's use part-whole language to tell me how to solve this problem. So I want you to pause the video for a second and think about how would you solve this problem using part-whole words. Remember, we have to combine parts to make a whole. So think about that in context of the word problem that we just talked about. Okay, so pause the video and then click play when you're ready to share. All right, friends, so we add the parts 2 plus 3 plus 1 to get the whole, which is 6. Okay, so you're going to draw a tape diagram on your whiteboard and use your counters to model the problem. So pause the video, draw a tape diagram. Remember, friends, a tape diagram is just where you're doing like part, whole, except for this part, you're not having to draw the whole, you're just drawing those parts, and then you can write the whole underneath it. Okay, so pause the video, draw your tape diagram with the information from the word problem, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. All right, so here are my parts. Okay, so one represents Jane's bag with 2 apples. This one represents Sam's bag with 3 apples. And this one represents Anne's bag with 1 apple. Then in a tape diagram, what I would do is I would draw this little bracket here, and then I would write the total underneath. So that's how we're using our tape diagram to do part, in this case, whole. There's 3 parts that make up the whole. Okay, so I can easily count those, right? And that would be 6. So how would this model be different if there were equal groups of 2 apples in each bag? So go ahead and pause the video, show the change on your model, and then click play when you're ready for the next step. All right, pause if you need more time. Okay, so I would take this one and I could move it right over here. Is that what some of you did? Okay, awesome. So that's because you notice that the boxes represent the groups and that the counters inside are the number or amount in each group. Okay, so our number of groups for this one didn't change, but the amount in each one changed. Let's change our model to show numbers instead of counters. So what number should we write in each box? Well, how many counters are in each box? We had 2, so we would write 2 in each box. So go ahead and remove your counters and write 2 in each box. So pause the video, remove your counters and write in the numbers, and then click play when you're ready for the next step. All right, so I'm going to remove these and put in my numbers. So what do we know when we add the parts? What are we trying to do? Yeah, we're going to add them to find the whole. So it's easy to see the repeated addition now with those numbers, isn't it? Yeah, because you would just kind of stick like a plus sign in between and you would have your repeated addition sentence. So write the repeated addition equation to find the total for this tape diagram. So that means you need to solve this problem too. Write the equals and then your sum. So pause the video, do that, and then click play when you're ready for the next step. All right, so here is my repeated addition. There's 3 groups, so I would have 3 2's in my repeated addition, and 2 plus 2 plus 2 equals 6. So we're adding units of 2 in this one because they're in groups of 2. Okay, so draw a tape diagram that has 4 parts. So pause the video, just draw the 4 parts, and then click play when you're ready for the next step. All right, friends, pause if you need more time. Otherwise, here are my 4 parts of my tape diagram. Use your counters to show 2 in the first group, 3 in the next group, 5 in the next group, and 2 in the last group. So it should look just like this. So go ahead and pause the video, place your counters in the groups or in each group, and then click play when you're ready for the next step. All right, friends. Okay, so our next question for you is, are all the groups equal? Nope, they sure aren't, right? They are not equal. Okay, friends, so move your counters to show equal groups of 3 in each part. So pause the video, move those around, and then click play when you're ready for the next step. All right, friends, so I'm going to move those around. So we have 4 equal groups of 3 now. If you remove your counters, what number will you write in each group? Yeah, 3, because there's 3 in each group. Remove your counters and write the number in each group. So pause the video, write your numbers in each group, and then click play when you're ready for the next step. All right, pause if you need more time. So we're going to take these out and put 3 in each one. Write the repeated addition equation that is related to this model and then solve. So pause the video, write your repeated addition sentence and solve, and then click play when you're ready to go over it together. All right, pause if you need more time. Otherwise, here's my repeated addition sentence. 3 plus 3 plus 3 plus 3. I have 4 3s because there's 4 groups with 3 in each group. We can model that and say the total by putting our bracket in there and writing the total underneath. So 4 groups of 3 is, it's 12. Okay, so now how would the tape diagram change if there were 3 groups of 4? So draw your new tape diagram and write the repeated addition equation that matches your new model. So pause the video, and now you want to show if there were 3 groups of 4, what would that tape diagram look like? Write your repeated addition and solve, and then click play when you're ready to go over it together. All right, friends, make sure to pause if you need more time. All right, so here is my tape diagram where there are 3 groups with 4 in each group. My repeated addition sentence would be 4 plus 4 plus 4. There are 3 4s because I have 3 groups. And we could model that by saying this equals 12. So 3 groups of 4 is 12. You got it. All right, so let's draw a tape diagram that shows 4 groups of 5. So go ahead and pause the video, draw your tape diagram that's 4 groups of 5, and then click play when you're ready for the next step. All right, friends, pause if you need more time. All right, so here is my tape diagram of 4 groups of 5. My repeated addition sentence is 5 plus 5 plus 5 plus 5 equals 20. So we can show this total is 20. So 4 groups of 5 is? That's 20. Awesome. All right, so now you guys are going to independently apply what we have learned in this lesson. So we're going to do our application problem. It says the flowers are blooming in Maria's garden. There are 3 roses, 3 buttercups, 3 sunflowers, 3 daisies, and 3 tulips. How many flowers are in all? Draw a tape diagram to match the problem and write a repeated addition equation to solve. And then click play when you're ready to go over it together. All right, friends, pause if you need more time. Otherwise, here we go. All right, so here is my tape diagram. My first group is the 3 roses. The next group is the 3 buttercups. The middle group is my 3 sunflowers. The next group is the 3 daisies, and the last group represents 3 tulips. Okay, because there are 5 groups total between the flowers, and there's 3 flowers in each group. My repeated addition would be 3 plus 3 plus 3 plus 3 plus 3 equals 15. So there's a total of 15 flowers in all. Did you guys get that? Okay, awesome. If not, rewind the video and watch my description again. All right, so good job, friends. All right, sweet. You guys did a wonderful job using tape diagrams to represent the equal groups and relating the groups to repeated addition. So fantastic job. Please head back on over to the module to see what you need to complete for your independent practice. As always, if you have any questions, please let me know. I'd be more than happy to help. And I hope you guys have a great rest of your day. Bye, friends.